Hello everyone, this is the Mining Geologist and I am back again with another very exciting and very informative tutorial. This tutorial is the second part of the Drillhole EDA tool that I showed you in the past 2 weeks. Now, this tutorial is going to be divided to two parts. In the first part, I'm going to show you how you can use right now the Drillhole EDA in your Python code. And of course, it's going to be totally free and anyone can now install this tool on his computer. So the second part is going to be a new update that I've added to the existing user interface that is available for free online. You'll find the link to that user interface in the description below. So I'm going to cover that in the end of this video, and I'm sure that a lot of you are going to like this new update. So if you're new to this channel, I cover things about geology, mining engineering, and geoscience in general. So you can support me by subscribing, liking my videos, or you can be a member of this channel or support me on Patreon. I will leave the links down below, in which you will have access to all the scripts and things that I share on this channel. And there are some members only videos like this one here. It's a members only video. So if you're a regular subscriber, you're not going to be able to watch this video. If you're a member, then this is something that you could watch. So without further ado, let's get started. Okay, so what I'm going to cover in this first part, I've got a really simple script here just to show you how you can use the Drillhole EDA in your Python code. I've got an example. I'm going to be covering the same things that we've covered in the user interface in the previous tutorial, but I'm going to show you now how you can do that in your Python code. Maybe you would like to automate this one. Maybe you would like to integrate this in an existing workflow that you have. So for people who are familiar with Python, this is for you. But if you don't want to use Python and if you want to still use the user interface, stick around because I will show you in the end of this video how you can use the new tools, because I've added some new updates to the existing user interface. So basically what I'm doing here is I'm importing pandas as PD. So basically, if you don't know Python, basically what I'm doing here is from now on, I'm going to be calling the pandas library PD. And then this is the library that I've created. It's called Drillhole EDA. And the way to install that, all you have to do is to go and do pip install drill EDA. So the version now is 0.1.4. So if you see there's something that changed in here, maybe I fixed the bug or I've added new features. So the features that I'm going to show you near the end of the video that I've added to the user interface, they are not available yet in the Python version. But if you'd like to take the script of the user interface, it's going to be also available in my Patreon page. But for now, these features are not available, but I'll make sure to add them to this library. Now, for people who are familiar with Python, they will be thinking maybe, why didn't you create just do an import, like import Drillhole EDA and that's it? The way I did it now, it's inside a class called Drillhole EDA because I'm planning to add a lot of other tools that will be available in the future. For now, all the things that we're going to be using is inside the Drill EDA class. So with that being said, let's move to the next code. So basically what I'm doing here is I'm importing a CSV file. Basically, this is your regular assay file in which I have the drill hole IDs, the from, to, and basically some numerical data. So it could be like grades or anything like that. Then I've got the geology here. It's your typical geology table or lithology table. So in which you'll have, again, the drill hole ID. Make sure that they're the same IDs written the same way. These are basically the tables that you're going to use in your typical geological modeling or mining software. So, and if we take a look at the geology table, you can see that I've got the ID is called, or the whole ID column is called ID. Then we've got from, to, and this is basically the lithology, or the column in which we have the litho codes. Then I'm looking at the lithology or lith column here. I'm looking at the unique data. This is basically to check all the unique lithologies I have in that table. And you can see that I've got like 7 unique lithologies. I've got S2, SH, ST, and so on. Now, if we look at the assay table, again, you can see that I've got from, depth from. It's not called from like in here. It's called depth from, depth to. I've got only one numeric field, which is for gold, AU, and I've got the whole ID and the sample ID. So the next thing that I will do now, I think for everyone who's familiar with Python, this is basically basic pandas, creating a data frame and checking the data frame, checking the unique values in a data frame. I think that's basic stuff. But now is the part how you can use the tool. So the first thing that you will need to do is, like in any mining package, you need to define certain columns. So you create a variable. It's basically a dictionary of values. So basically we're saying that the whole ID column is this ID column. So whole ID, this, you should not change this one. It should be called whole ID, because this is basically how the library is processing these columns in the background. It's renaming the column. So if in your geology table the whole ID is called ID, when you import that, the library is going to rename that whole ID in the background. So we're saying that the whole ID is basically ID in the geology table, the from is from, the to is to, and the rock field is the lithology. Then we've got the assay columns. Again, the whole ID is whole ID. You can see that in the assay table, it's not called ID, it's called whole ID. And make sure that you write it the same way it's written here. Then we define the from, to, and for the assay columns, for this key, you give it a list. So if you have multiple numeric fields, let's say you've got gold, copper, and other numeric fields, so all you have to do is to create a list and add these numeric columns to that list. So these are called the assay columns. Then what we are going to do now is we are going to create a drill EDA object. We assign that to a variable. In this case, I'm going to call this EDA, and from now on, we're going to use that object. So the first thing that I would like to do is to validate the whole IDs. That's what we've done in the app. So we make sure that there are no missing holes, anything like that. But if there are missing holes, it's going to be written here. So this EDA validate whole IDs, you give it the geology table, the assay table, the geology columns, and the assay columns dictionaries that we've created, and it's gonna validate the holes. So basically it's gonna say that there are no missing holes in the assay table or no missing holes in geology table. If there are missing holes, it's going to list that for you. Then we are going to do EDA process data method. So for this one, you give it the geology table again, the assay table, the columns, the geology columns first, the assay columns second, and then you set the combine lithologies to true. If this one is set to true, then this one is going to be activated. If it's set to false, it's going to leave the geology table as is. If it is set to true, then the lithology groups, you're going to give it a dictionary of groups. So we're going to say you give it a tuple. So in this case, we're going to say we want to merge S1 lithology and SH and SH. And now the new name for these, it's going to be, the combined name is going to be SSS. Okay. So let's say you want to add another group. All you have to do is to do a comma, then create a tuple of the lithologies that you want to combine. So you add a comma, then the lithologies here, let's say again, I'm going to do like S2, S2 and SH. the same way you did with that one, and then you do like the 2 points, and let's say you call this I don't know, like GGG. So that's how you do it. So you can create any number of groups that you want, and it's that easy. So for now, I'm gonna leave this we're gonna combine just S2 and SH, and I'm gonna call that SS. So if this one is set to false, even if I set this, if I create a group in here, it's not gonna be used. It's not gonna create that group for me. So keep that in your mind. So this one needs to be set true for this lithology group to be activated. Then if I print the process data, you can see that now that SS, S2 and SH, which is, if you look at the geology table, you can see that S2 and SH, so all the way to like 6 meters of depth. Now all of that is now called SSS, but it is divided by the intervals of the assay data, and you can see that it's assigning the different assay numeric data to these different intervals. All of these are the same lithologies, but we've got different grades for each one of these samples. Now, if we set this to false, you'll see that this is going to be back to the original lithology. Now, what I can do also is I can check, or maybe let's say that I'm interested in exporting that combined lithology without the grades. I can also do that by doing, let's say, I create a new variable called new geology, and then that EDA, I can get the combined geology. If I print that, I will get the new combined or the new geology table. And you can see now from 0 to 6, I've got that SSS lithology, and I can see I've got that also here. Now, what I can also do is I can assign two variables to this EDA get or waste tables. I give it the grade column, which is AU in this case, and I give it a cutoff grade, and based on that, I can see the possible ore lithologies with the average grade in these different domains. So like you can see, like the IN here, like the average grade is 9.15, the MU is 1.993, and so on. So if I change the cutoff here, this one is going to be updated based on that. The possible waste is basically everything below the cutoff that I assigned in there. So you can change the grade field here, or you can change the cutoff grade also here, and you assign that to two variables. You can call them whatever you want, maybe ore and waste, and it's going to list all the lithologies based on that cutoff and this numeric field. Again, if you're interested in specific statistics or descriptive statistics of a specific lithology, let's say I know that the average of the gold in this lithology is 0.36. So let's say I want to see the maximum, the minimum, and so on inside the specific lithology. What I can do is I can create a new variable. I do EDA get descriptive statistics, and I give it that lithology, which is the SSS. Basically, this one is the combined lithology, and I will get the grades. If I have multiple numeric fields, we'll get all the different statistics for these numeric fields inside that specific lithology. So in this case, you can see that we have 346 samples inside this SSS lithology. This is the mean of gold, and you can see that standard deviation, minimum, maximum, and so on. Now, if you guys remember, we've got also some plots. One of them is the scatter plot. So basically what I can do is I can define a categorical filter. If you remember, guys, we've created a categorical filter and a numerical filter. So basically the categorical filter is going to be rock, which is the field that we're going to use, the categorical field, and we're interested in these three lithologies. So basically you give it the name of the column, and you give it the list of the lithologies or the categorical data inside that categorical column. this is going to be used as a filter. And then we can also set a numerical field or a numerical filter based on a numerical field. In this case, we're going to use the gold again as a filter, and we are going to define a min and a max inside a list here. So basically 0.5 is the minimum, 2 is the maximum. Then we create a scatter using the gold. So gold is going to be on the x-axis. In this case, since we have only one numerical field or one element here. So in this case, we're going to use from just to show you how it works. This is going to be the x-axis. This is going to be the y-axis. We can control the dot size. It's set to 5 here. The dot color is set to blue. You can use a hex color in here if you want. The font size of the text is set to 14. Then we're going to use that categorical filter. You can set this to none if you don't want to filter the data. And this is going to be the numerical field. Again, you can set this to none if you don't want to apply a numerical filter. So we're using this one. And then again, the number of X ticks, this is basically the ticks that we're going to set in there, is set to 10. And this one is set to 10. And then you can change the title of the plot. We can do the same thing for the histogram. It's exactly the same thing. We can use the filter here. We can set the barcode color. We can define a capping value. It's set to none there. You can change the bin size. You can set it the log scale equal to true or false. And then you choose your numerical field in here. It's using EDA.histogram. So it's really that simple. Again, for the box plot, you do the same thing. It's basically EDA.boxplot. So you give it the numeric field. It's AU again, the categorical column that will display the on the y-axis the different lithologies or your categorical data. In this case, we're going to use rock. Just one thing to mention here. So when you import the lithology table, it's being renamed to rock. So whatever is the column name of your lithology, if it's lith, if it's rock, if it's I don't know, like geology, it's gonna be renamed rock in the background. So if you want to use the lithology table, make sure to use the uppercase rock in here. Then these are the categories that we're interested in, the MU and the IN. Then the box fill, it's set to true, so the boxes are going to be filled. The circle size, it's set to 1, and you can change that if you want. The font size set to 14, and the this is basically the title of the box plot. And then you can use the log scale. You can set that to true or to false if you want. And then you can use the same filters that we used for the scatter plot and the histogram. So these are the only available plots so far, but these are going to be very helpful. And now you can use this one by just doing pip install drill EDA, and you can use this in your Python code. So you can use it in an existing workflow, or you can start using this one before doing any geological modeling. But now let's go to the user interface and show you what are the new features that I've added to the user interface. So if we jump to the Drillhole drilleda.streamlit.app, you can see now, if you guys remember, we've got like the data processing and visualization in the past, but now there's a lithology analysis. So what are the things that we can do now? So basically, when you import your geology table and you define all the different columns that you need, so the lithology analysis tab is going to show you first the lithology summary. So what is this? So this one is going to list all the unique lithologies. In this case, it's going to be ST, S1, SH, and so on. Then it's going to show you this column, the percentage of drill holes. So basically, in how many drill holes we have this specific lithologies. So 100 means this lithologies is in 100% of the drill holes. So every single drill hole that we have, there is this lithology, the ST. So basically, the IN, for example, here, if you guys remember, we have only like 68 samples. And you can see that this one is in just 90% of the drill holes. So it's not in all the drill holes. The other thing is the average occurrence per drill hole. So basically what this one is doing, or what this one is saying, is like how many intervals of this same lithology we can have in the same drill hole. So this one is creating an average value from all the drill holes. So the higher the number, it means that the same lithology appears at least more than one time in the same drill hole. So for example, if you see 1, it means that this specific lithology appears only once in each and every single drill hole. So if you see, the average is 1. And if it's like 1.16, for example, it could be like in a couple of drill holes there are like 2 different intervals, but in most of them maybe it's just 1 sample per drill hole. In this case, you can see for the ST it's 1.8, which means that I think in most of the drill holes we have like 2 samples, and sometimes maybe 3 samples, and we have like 1 sample and so on. Now we also have the average thickness. So what is the average thickness in all the drill holes? We've got the minimum thickness and the maximum thickness. So this table is already giving me a lot of information, and now I can start to think about, oh, I've got this lithology that appears twice in my drill hole. I need to find a way to deal with that. So maybe I'm gonna create like ST top and ST bottom so I can deal with that when I'm doing my geological model. So this table is already giving us a lot of information. Now the other thing is that we know that in most of the geological models, maybe you have like an overburden and you have like a bedrock. That these are basically the 2 easiest probably to set up in your geological model. So this one is going to give you an idea about that. So you can see that the first lithology, so this one is checking what is the first lithology in all the drill holes, and it's saying that in 73% of the drill holes, the first lithology is S2. And out of that 73%, 66% of the time, the next lithology after that is SH. So then 20% of the time is this B lithology, 3% is MU, and 2% is SH, and then and so on. So this one, it gives you a really good idea about what is the lithology that always appears on the top, and then the one exactly after that one. You can see, for example, when the lithology is this B lithology, which is just in 20% of the holes, the ST is always after this one. So now we're getting that chronology in our mind, and now we start to think about what is the chronology that we're going to use. And the next thing is basically the opposite. So what is the last lithology in the drill holes? You can see that we've got only 2, so maybe this is our bedrock. You can see that it's ST, and then it's the MU. In just 1% of the drill holes we've got the MU, but in 98% of the time it's ST. And what is the one above that directly? In 48% of the time for the ST, when it's ST, it's a QV1. And in just 1%, which is the MU, the one above that is again the ST. So now we get this idea about the chronology, and maybe this is going to help us like define, maybe we can probably decide on merging 2 of these. And by the way, if you do combined lithologies, this is going to help you again by seeing, for example, you can merge these 2 and now you can see the different stats, and it's going to help you like define your domains. But there's one more tool which is very helpful, which is the top lithology sequences. That's what I've called it. So basically what this one is doing, it's giving you like what is the typical lithological sequence in these drill holes, and what is the percentage of the holes that they have this specific sequence. So it's showing you maybe here in 15% of the drill holes, we've got S2, SH, ST, QV1, and ST. So I've got this specific sequence in like 15% of the drill holes. And then again, we've got the same, we've got another 13.8% that are just S2, SH, ST, and MU. Maybe what I can do now is I can check what is this MU and what is this QV1. Maybe what I can do is basically I can combine both of these, so I can combine both of these percentages, and I will have like a very defined chronology already. And you can see that the next one, which covers 10% of the drill hole, is this B lithology, and then just ST. And then you might be thinking, what are these thicknesses? This is basically ST. This is the average thickness of the ST in all the drill holes. So we're using that to define this specific thickness. So this is like a typical drill hole, but it's not a specific drill hole. So you see that the typical thickness of the S2 is this thickness. And for SH also, you can see that the ST is pretty thick in most of the cases. And yeah, it's the same thickness for all of these because it's the same average thickness for the ST lithology. But this one is going to give you a really good idea about what is the chronology of your deposit and how are you going to define your domain. If you think that 2 sequences are not enough, you can make maybe like you can update this one to like 4 sequences or 5 up to 10 sequences to see what are the top sequences in your lithology, and then this is going to help you define what combination you're going to do. You can see, for example, here the only difference is like 9.6%. We've got a QV layer between 2 ST layers. So, and this one is going to give us a really good idea about what lithologies we're going to combine. Maybe we can combine both of these and combine both of these, and we're going to end up with maybe like a typical chronology that covers, I don't know, like 50% of the drill holes that we have. So this is a really great tool. I think anyone, before starting your geological models, you can start using this one, and it's gonna save you a lot of time. Trust me, I use this one. It saves me a lot of time when I'm dealing with geological models. And yeah, again, if you're interested, if you think the tool is slow because it's uploaded on a public cloud server, you can get this one by clicking on the download source. Basically, you need to be a Patreon, of course, and I will upload the latest version. It should be there now for the Patreons. You can download this one and run it locally on your computer. And for everyone else, you can use it for free. And stay tuned. I will add probably in the future these features to the existing Drill EDA tool. With that being said, I hope this tool is very useful for you guys. Let me know, what do you think? What other things that should I add? And with that being said, see you in the next video. He's the mining geologist, here to show you all the things that you might have missed. He's got plenty of software tips and tricks for your geoscience lives. So get your fix of mineral exploration and mining engineering information, and check the links, leave a like, and please subscribe.